There are two airport and airfield pavement rating methods in DAPS at the moment: Acn Pcn and Acr Pcr. Acr Pcr is the method that is going to be the official standard from November 2024 forward. So we are going to describe it with a little bit more of detail. In order to calculate ACR PCR or ACN PCN, basically we need two distinct informations or sets of information. We need pavement data, which is the same thing as to say the number of layers, type of materials embedded in the layers, and their estimated stiffnesses and thicknesses and actual thicknesses. So that is one piece of the information. The other piece of the information is the airplane mix that is expected to to traffic and to use the airport and airfield infrastructure. DAPS has a very wide library of airplanes and airplane models. The way that the information is described is by the brand of the manufacturer. So it starts alphabetically from A to Z, and under each manufacturer, there's a list of aircraft that um, that are built by that specific producer or manufacturer. If we click on a particular type of airplane, DAPS will automatically provides us with more information, such as the overall weight of the aircraft, the load that is applied on each wheel of the main landing gear, pressure, and the pass to coverage ratio. It also shows us a graphic with a representation of the wheels of the main landing gear. So in this case, we have 6 wheels per each of the main landing gears. And it also provides us with a bit more of information regarding the ACN, PCN, and ACR, PCR determinations here. So we have the alpha factor that is used for PCN. We can determine its the aircraft that is selected flexible ACN. We can visualize its load placement. So in this graphic, assuming um, a specific wonder that is specified here, that usually assumes two distinct values, 1.79 meters or 0.88 meters, but that we can select to any other value that we wish. And the way to interpret this graphic is that each of these single black lines corresponds to the coverages of one single wheel. In this particular case, we have along the longitudinal we have 6 different wheels in 2 different alignments. So we have 3 wheels per alignment. If we visualize the load placement, each of these um, each of these black lines represents the overlap probability. So if we have the overlap probability for one, of course, if there's one, but there are 3 in the same alignment, we're going to have one, the second, and the third, and the total probability is represented by the blue line. So this blue line basically is the sum of all of the individual of distinct individual um, probability lines of each single wheel or wheel wheel in the landing gear. We can also determine the ACR for flexible ACR and its counterpart, the rigid ACR. Now, in order to start to calculate PCR, all we have to do is select the airplanes that we want to consider and add them to a hypothetic to a particular aircraft mix. So let's say that I want to add this particular airplane, and I want to also add this particular airplane, and I want to add. So I'm selecting them absolutely random way, and I want to select this particular airplane. So I've already selected four. Now I move to the traffic mix separator. As you can see, these are the aircraft models that I've selected previously. Now I have to define the departures. And before I define the departures, I can go to the main settings tab, and there are basically these two distinct um, configurations for departures. One is for the first configuration is for the total period. So if I introduce the total period, I have to manually, if I select total period, I have to manually introduce the number of expected departures for each model of airplane for the total period. But let's say that or I can have the I can introduce the traffic on a yearly base. So let's say that I have these are the so let's say that I have a yearly base and I want to calculate PCR for a period of 20 years, which is basically standard. That I want to have uh, a growth rate of 3% per year, and that in the year zero, this this is the traffic that I have, or the number of departures that I have is this. And you notice that as I introduce the number of departures, the lines that correspond to each airplane move from orange to green. Once all the information regarding every aircraft is complete, all of them become green, and this graphic appears. So this graphic shows us the base aircraft departures, meaning the aircraft departures expected for year zero, and if I consider a period of 20 years and the growth per year of 3%, DAPS will automatically calculate the expected traffic of each model of airplane for the total period, considering a growth of 3% a year, that is equally applied to every single model of airplane. Other things that we can also configure are the traffic cycles per departure, but that depends on the configuration of the airport or of the airfield, because just depending on the way that the infrastructure is planned, a single departure can can produce more than one passage of the aircraft in a single pavement section, in a possible single pavement section. Once we have the aircraft models and their corresponding departures correctly defined, meaning they are all accepted by DAPS and in the green color, we can save them to file, so that we can. It's not necessary to save to file, but if we save this information to file, we can load it later at sometime in the future if you want to repeat the calculations, or if you want to check if everything is okay. So we only need to do this once, and then we can use the information for later. So going for a test PCR calculation, we can load the pavement section, because these pavement section files are exactly the same, and conveniently are exactly the same as we saw before in the FWD/HWD by calculation module. So I can load a particular pavement section, and I can also load a previously established airport traffic mix. So once I have these two variables in the process, namely the pavement structure and the expected traffic for that pavement structure, all that I have to do to calculate PCR is go to the Analysis and Results tab, select the PCR button, and in a few seconds, DAPS will automatically calculate the PCR that corresponds to that particular um, combined information of pavement structure and expected traffic. here, this table that summarizes the process is once again very easily copied to a spreadsheet or to a text processing software. All we have to do is select the copy to clipboard option and then paste it into any of these particular software. Um, so we can visualize the damage. The damage, each line, each color corresponds to a specific aircraft model and its number of expected repetitions. And the total damage that we can see represented by this dark line, by this black line, is the sum of all of the others. So if we sum the damage of all of these individual aircraft, we are going to have um, this total damage line. And DAPS is telling us that the section, so this graphic here, this zero is x distance. This x distance is the center line offset, so 0 is the center of the runway or of the taxiway or of the apron or any part of the airport or airfield infrastructure, and um, it's only representing half of so it represents the transverse section of the infrastructure, be it runway or taxiway or any other part of the airport, and it only represents 50% because the other part is absolutely symmetric. So we don't need to represent um, the left and right part, the left and right sections of the airport pavement infrastructure, because having one, we have the other one will be directly symmetric, so there's no need to represent both of them. In this case, DAPS is telling us that the point of maximum damage occurs at 3.13 meters, which will correspond to somewhere around here. Um, so every time that you see this star here, some of the columns have a star. So every time that you see a parameter that has a star, that means that that variable corresponds to the section of maximum damage, which in this case is 3.13 meters of offset, 3.13. But accordingly to each pavement structure and to each expected traffic at will be somewhere else. It changes from place to place accordingly to the airport traffic and to the pavement structure. So we can also visualize the coverage map. We can see that the airport, the airplane model that is expected to use the infrastructure with more regularity is not the model of airplane that causes the maximum damage, because each airplane has its own properties, its own weight, its own weight distribution, its own landing gear arrangement. So it just because it uses just because a particular model of airplane is expected to use the infrastructure of the airport more regularity, that does not necessarily mean that it will be the critical airplane or the airplane model that will cause more damage. So now, if we select any particular line that corresponds to an airplane, we have these two distinct options that will automatically calculate a representation of the subgrade strains caused by the main landing gear of this particular aircraft on the subgrade soil of that particular pavement structure. So I can enlarge it to occupy the full window of the depth. I can move back to its normal configuration, and as always, we can copy to clipboard the graphic and we can save it to file. It's very easy to get the information out of the software. And we can also obtain the exact same representation for this aircraft model or any other if we select the 2D representation. So this will be exactly the same thing, or approximate, but in a 2D representation as viewed from above. If we see best, and if I So this is a 2D representation. This will be the same thing, but in a 3D representation. If we wish to visualize it from above, it will be something like this, which was what we were visualizing before. So it's 2D versus 3D. Um, so all I had to do was introduce the traffic mix, introduce the the pavement structure, define the number of years that I have for the calculation and the expected growth per year, define the lateral wonder, and then go to the analysis and results settings and determine either the PCR, which is done automatically, or if I want to calculate PCN, it will be exactly the same thing. So it's as easy as this.